everyone, welcome to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 11th, and that is your class is your 14. We had done your 13th class in the last session, where we had done after before this 13 classes we had done your units till unit 7, that is unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7. That is in the last classes of this. Now this is for class 11. So we had done in part 2. Part 1 we had completed. Part 2 is your unit 8 is your redox reaction, which we had completed, and this is will continue with unit 9, which we had started in the last class. That is unit 9 is your hydrogen. So in hydrogen we had started up and we had discussed many or more of related to the Clark's method and boiling. We had done in terms of it many more topic we had done, even though now we talk about for continuing the another unit 9, that is being the permanent hardness. So let's go for it. We had done your temporary hardness in the last class. So in permanent hardness, what it is stands for, I had told you in the last class only, so we'll continue with the same. In permanent hardness, here it is due to the presence of soluble salt of magnesium and calcium in the form of chlorides and sulfates in water, where that permanent hardness is not removed by boiling, which has been removed. That in temporary hardness we had, that has been removed from boiling, and that can be removed from the following method. For permanent hardness will be removed for the following method. But before starting with detail about it, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So we go for it, and the first method that will deal here is your treatment with washing soda, which is sodium carbonate. The first method, treatment with washing soda, which is sodium carbonate. Here, so in this here washing soda reacts with soluble calcium and magnesium chlorides and sulfates in hard water to form insoluble carbonates, and that will be having as here, which is NCl2 plus Na2CO3, which will give you MCO3 plus 2NaCl plus that is 2NaCl. So where this M which we had talked about it, this is M is equals, either it will be Mg or it will be calcium. It could be magnesium or calcium. Now we talk for another reaction also in terms of treating with the washing soda, which is sodium carbonate, which will be MSO4 plus Na2CO3 will give MCO3 plus Na2SO4. So this is the another reaction where the M is only it could be magnesium or calcium. Now we talk for the another one, which has been the another method is your Calgon's method. So in terms of Calgon's method here, the sodium hexametaphosphate, which is Na6P6O18, commercially called Calgon's, when added to a hard water the following reaction takes place. So the will be going to react, we're going to make a reaction here. Na6 P6O18, this is what we called as galgan. Okay, this is this is known as here sodium hexametaphosphate. Okay, and that is commercially called as galgans. So it will be 2Na plus plus Na4P6O18 minus, where M could be, with that as I told you, magnesium and calcium. So M2 plus plus Na4P6O18 2 minus, so it will be give you Na2MP6O18 2 minus, which will be 2 Na plus. So here the complex anion keeps the magnesium, which is Mg2 plus and Cu2 plus ions in solution. Now we have another one, which is ion exchange method. So we go for it. The third one, ion exchange method. Mostly they are not talking asking this ion exchange method. On the next we'll discuss about the synthetic resins method, but most important is treatment with washing soda, which is sodium carbonate, and the galgans method. So but it is in your course, so we'll discuss that. Ion exchange method. So here we go. So in ion exchange method here, this method is also called zeolite or permitted process. Hydrated sodium aluminum silicate is zeolite, which is permitted, and for the sake of simplicity, the sodium aluminum silicate, which is NaAlSiO4, that can be written as NaZ, and when this is added to in hard water, you have to exchange the reaction which is being take place. So we go for it. 2NaZ solid plus M2 plus aqueous will give MZ2 solid plus 2Na plus aqueous, which is being M equals to Mg or Ca. So here for that, it is permitted zeolite, that is said to be an exhausted when all the sodium in it is used up, and it is regenerated for further use by treating with an aqueous sodium chloride solution. So for the same, we go for the equation. MZ2 solid plus 2 NaCl was will give 2 NaZ solid plus MCl2, which is in aqueous. Now we talk for the another one, which is the another important one, which is permanent hardness. For permanent hardness, we'll discuss about synthetic resins method here. Synthetic resins method, where nowadays the hard water is softened by using synthetic cation exchanger, and this method is more efficient than zeolite process, where cations exchange resins contained large organic molecule with SO3H group and are water insoluble. Ion exchange resin, which is RSO3H, is changed to RNA by treating it with NaCl. The resin exchanges Na plus ions with Ca2 plus and Mg2 plus ion that is present in hard water to make the water soft. And here R is the resin anion. So we go for it. Plus M2 plus equals will give R2 M solid plus 2Na plus, which is in aqueous. So here for the same the resin can be regenerated by adding aqueous NaCl solution, where pure demineralized deionized water free from all soluble mineral salt that is obtained by passing water successfully through the cation exchange in the H plus form and an anion exchange in the plus of OH minus form, that is resins. So it will be 2RH solid plus M2 plus, which is in aqueous, give MR2 solid plus 2H plus here, that is your aqueous. So here in this cation exchange process, H plus exchanges for Na plus, Ca2 plus and Mg2 plus and other cation present in water. This process results in proton release and thus makes the water acidic in the anion exchange process. So it will be solid plus H2O liquid or NH3 plus OH minus solid, where R NH3 plus OH minus solid plus X minus aqueous will give R NH3 plus X minus solid plus OH minus aqueous. So here OH exchanges for anion like Cl minus and HCO3 minus and SO4 minus, etc., that is present in water. OH minus ion thus liberated neutralize the H plus ion set free in the cation exchange. So here H plus equals plus OH minus equals will give H2O liquid. So this exhausted cation and anion exchange resins beds are regenerated by the treatment with dilute acid and alkali solution, respectively. Now we go for another one, which is the hydrogen peroxide, which is H2O2. Let's go for it. The another heading we talk about it. Hydrogen peroxide, which is H2O2. Yeah. So for the H2O2 we talk about here. So for H2O2 here, that is hydrogen peroxide is an important chemical used in pollution control treatment of domestic and industrial effluents. And for the same, the first we talk about for the preparation. So the first we have for preparation. In terms of preparation, it can be prepared by the following method. first to acidifying barium peroxide and removing excess water by evaporation under the reduced pressure that gives the hydrogen peroxide. And for that we have your reaction here. BaO2 8H2 solid plus H2SO4 aqueous will give SO2 4 solid plus H2O2 aqueous plus 8H2O liquid. So the second one we have is your peroxidifying sulfate, that is obtained by the electric oxidations of acidified sulfate solution at high current density on hydrolysis yield hydrogen peroxide, and so that it will be 2HSO4 minus aqueous will give, in the presence of electrolysis, which is HO3 SO3 H aqueous will give, in presence of hydrolysis, 2HSO4 minus aqueous plus 2H minus 2H plus aqueous plus H2O2, which is in the form of aqueous. So this method is now used for laboratory preparations of D2O2, and that is K2S2O8 plus 2 D2O liquid will give 2 Kd SO4 aqueous plus D2O2 liquid here. So that is for the peroxo disulfate, and this method is now used to be the laboratory preparation for D2O2. And the third we talk about further another equation, and in terms of it, and that is your industrially it is being prepared by the auto oxidations of two alkyl anthraquinols, and that is for, it will be your 2 ethylenquinol. So it will be in the form, in the presence of O2, which is your air, and which is will give you H2O2 plus oxidized product. And in the case of 1% of H2O, it is formed, and it is extracted with water and concentrated to near about 30% biomass by distillations under the reduced pressure. It can be further concentrated that to near about 85% by careful distillation under the low pressure, and the remaining water that can be frozen out to obtain the pure H2O2 here. Now we talk for another one, which is being the another one, and that is your physical properties. So here we go. So in terms of physical property, here that we discussed, of course, and in the same way for the physical property, In a pure state, H2O2 is an almost colorless, very pale blue liquid, and it is important here that is to physical properties that will be given and that we'll discuss, of course. And H2O2 is miscible with water in all proportions and forms a hydrate, which is H2O2.H2O, where melting point is 221 Kelvin, and a 30% solutions of H2O2 is marked, and 1 milliliter, that is of 30% of H2O2 solution, will give 100 volt of oxygen at STP, where commercially it is marked as 10 volt, which means it contains 3% of H2O2 here. Now we go for another question in terms of related to the physical properties only. Here we go. So we go for the question, and the question we have here, you have to calculate the strength of 10 volume solution of hydrogen peroxide. But before that, we will be discussing the physical properties of hydrogen peroxide, so that it will be helpful to you to go ahead with the solution for it. So let's do first table. So physical properties of hydrogen peroxide. So physical properties of hydrogen peroxide. Okay, so first we have for melting point. The first we have your melting point by Kelvin. The another we have here is boiling point, which is here extrapolated. Another we have for vapor pressure. This is 298 Kelvin by mmHg. Another is density, which is solid at 268.5 Kelvin by g centimeter inverse cube. So here we go. So for that, melting point will be giving here as 272.4. Boiling point, which is your extrapolated, it will be 423. Vapor pressure, it will be 1.9, and density, which is 1.64. Now for the another one we talk here has been the next one, which will be your density liquid at. So we'll find out for the density. It is density solid. So density liquid at 298. So for that it will be another, we will discuss about the viscosity. Which is 290 Kelvin centipose. Another is your dielectric constant. and another one is your electrical conductivity. So for that 1.44, this is 1.25, another is 70.9, and then we have your 5.1 into 10 to the power minus 8. And that what we'll have to discuss here. So here we go for the next one, which we'll be discussing here. Now we'll discuss the question first, and then we'll discuss the rest of this. And the question we have: calculate the strength of 10 volume solution of hydrogen peroxide. So the question is, calculate the strength of 10 volume solution of hydrogen peroxide. This is what we have. Let's go for the solution here. So the solution here for this 10 volume solution of H2O2, solution of H2O2 means that 1 liter of this H2O2 will give 10 liter of oxygen at STP. So here 2 H2O2 liquid will give O2 gas plus H2O liquid here. This is your 2 into 34 gram, and here 22.4 liter at STP, and this is 68 gram. Okay, so 22.4 liter of O2 at STP is produced from H2O2, which is 68 gram. So 10 liter of O2 at STP is produced from H2O2, which is 68 into 10 upon 22.4 gram, which is equals to 30.36 grams. So therefore the strength of H2O2 in the 10 volume is therefore a strength of H2O2 in 10 volume H2O2, that is equals to 30.36 gram per liter. That what we'll be having here. So here we're going to end up with this, and other than this chemistry, we are dealing with the quantitative aptitude, where we had started with arithmetical ability, and we are on half of the topic we had done in the part 1. Now coming towards this, we are dealing with the physics as well. We are dealing with physics part 1 for class 11 physics NCRT. In terms of physics chemistry, coming towards it, so yes, in terms of chemistry, we are dealing here In that we had completed your first part 1 for class 11, where in that unit 1 which we had completed, that is your some basic concepts of chemistry. Unit 2 is your structures of atom. Unit 3 is your classifications of element and periodicity in properties. Unit 4 is your chemical bonding and molecular structure. Unit 5 is your states of matter. Unit 6 is your thermodynamics. Unit 7 is your equilibrium. In terms of part 2, we are dealing with unit 8, which we had done your redox reaction, which is the classical ideas of redox reaction, oxidation and redox reaction in terms of electron transfer reaction, oxidation number, redox reactions, electrode processes. On the same way, unit 9 which we have to cover up is your hydrogen, which we had to cover up near about it. That is your the positions of hydrogen in the periodic table. Dihydrogen, which is H2, preparations of dihydrogen, which is H2, and properties of dihydrogen, hydrides, water, and hydrogen peroxide, which we had done, heavy water, D2O, which we had done, and dihydrogen as a fuel we have to do. And after that we'll complete that. After that we'll discuss unit 10, which is the S block element, unit 11 which is the P block element, which unit 12 is your organic chemistry, some basics principles of technique. Unit 13 is your hydrocarbons, and unit 14 is your environmental chemistry. So all these we have to cover up here, and that is all what we will be discussing. And thank you for your support. Please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.